The Kingdom of Bhutan, a small country in the spectacular Himalayan foothills. In between valleys of breathtaking beauty. In 1994, it experienced the worst natural disaster in its history. 18 million cubic meters of water flooded a major valley, burying it under 5 million tons of boulders, debris, and mud. The oldest part of the coronation monastery of the present-day Wangchuk dynasty in Punakha was almost completely destroyed, and 20 people lost their lives. The cause of this catastrophic flood was the bursting of a glacial dam located 4,000 meters above the valley floor. Lowering the water level of another lake at an altitude of 4,500 meters, by deepening, the lake outlet revealed that this alone would not sufficiently reduce the risk of a similar catastrophe. As a result, the Royal Bhutanese government contacted Professor Hermann Häusler to head an international team that would investigate the complex environmental system of the glaciated area in northern Bhutan. On arrival at Thimphu, foodstuffs are purchased in the local market. Detailed planning is important as the expedition will have to be completely self-sufficient for several weeks. Since only the first stage of the journey can be made by road, the tons of equipment and supplies have to be packed in a manner suitable for transport by pack animals. In Tashitang, the end of the road for vehicular transport is reached. From there, it is the domain of horses and mules. Ensuring an even load distribution on the animals presents a tricky problem requiring careful planning. A march of several days follows along the Mo-Chu River to Takshi Makang near the border with Tibet. From the lowlands up to an altitude of 2,400 meters, the route passes through rice fields, which form the focus of life for the majority of the rural population. Rain and mist prevail during the subsequent daily marches, as the rainforest lives up to its name. The expedition struggles on up to an altitude of 3,500 meters, where the next camp is close to the tree line. This is now the limit for using horses and mules as pack animals, so they are replaced by strong yaks. These massive oxen with thick furry coats and impressively sharp horns are optimally suited to high-altitude conditions. For yaks, too, it is important to carefully tie the boxes onto their backs and to balance the loads in order to guarantee the necessary freedom of movement. A freedom which powerful bulls sometimes like to take advantage of. This last stage of the journey to the study area, a further 1 week's march, requires the utmost effort from both people and animals.
Yeah. Shut this.
The route leads from Takshi Makang via Hedi to Lunana. Drawing on their last reserves of energy, the caravan continues, far away from any type of infrastructure. The ultimate challenge still lies ahead. Karchung La, the highest pass on the route, at an altitude of 5,200 meters. This route, known as the Snowman Trek, covers a distance of 120 kilometers. Because of the rugged terrain and extreme altitude, the Snowman Trek to the remote Lunana district is said to be one of the most difficult treks in the world. Time is of the essence, as the extreme conditions permit only a brief window of opportunity for scientific investigations before the snow returns and the high passes are once again closed. The cold eats into one's bones, but the greatest danger is from the high altitude and the weariness caused by the low oxygen content of the air, which makes each step seem like an ordeal. In this situation, a break in the cloud cover encourages the expedition, and a few hours later, the study area is reached. The group pitches its tents in a valley, shaped in the past by the enormous power of glaciers, and filled with material from glacier lake dam bursts. Without delay, the international team applies itself to the expedition's objective, using extensive scientific investigations in numerous disciplines to reconstruct a picture, like the pieces of a jigsaw puzzle. A picture of the glacial dam burst catastrophe. Satellite images and a detailed topographic survey provide the basis for geological and geomorphological mapping and for recording the results in a geoscientific information system. The stability of the moraine dams is assessed by geophysical measurements and by soil mechanics investigations. Many techniques are focused on the lakes themselves, as well as biological, chemical, and hydrological surveys. Echo-sounding permits computer calculation of the water volume. The recharge from moraine springs, the so-called seepages, as well as the discharge from lake outlets, provide important information on the hydrologic cycle. The last piece of the environmental puzzle is provided by data from an automatic weather station, which allows the correlation of air temperature and precipitation with glacier melt and river discharge. The combination of different surface and subsurface data enables the research team to calculate the most probable scenario responsible for the 1994 flash flood. The retreat of a glacier is caused by melting processes. If the glacier has piled up a moraine dam, a glacier lake comes into existence and will continue to grow as the glacier melts. Under normal conditions, the recharge and discharge of such a lake are in balance. This situation immediately becomes critical, however, if a sudden mass movement, such as a rock fall or ice fall, causes a flood wave which bursts the frontal moraine dam. This probably happened as part of a chain reaction in Lunana in 1994, when a flood wave from Drukgyung Lake also affected the Lugye Lake, causing a large secondary flood wave which then burst the moraine dam of the Lugye Lake. Even today, The valley bears a silent witness to the enormous devastation of this dam burst. The danger is an ever-present one, with a comparison of satellite images showing a rapid retreat of glaciers within the space of only a few years. A worst-case scenario is calculated by the Austrian research team to have a predicted volume 3 times the size of the 1994 Lugia dam burst. Based on this scenario, a hazard zonation plan was computed for the endangered villages, delineating zones of different flood risk. 4 years of investigations have now come to an end. The implementation of the results is now the responsibility of Bhutanese officials.
And if we can control the speed of the flow through construction of dams at regular intervals, it would definitely assist in minimizing damages en route. The other option we have is of undertaking land use planning for the future, at least based on hazard zonation concept, where we will identify the more risky areas and then undertake proper planning so that the loss to lives and properties are minimized through this kind of planning.
In summary, the challenges are great and the responsibilities are high, as Bhutan's 2,500 glacier lakes are all filling up with meltwater and many are at risk of bursting. Many spheres of interests have to be taken into account. Hydropower schemes and irrigation reservoirs are planned in the main development zones of the valleys, and retention dams are under consideration. The ultimate goal of the scientists is to protect human lives, here in Bhutan, on the roof of the world.